Hi, I'm Eric Thompson, and in this video, I'll be going over 101 ways to run Python code. I'll be starting with read-eval print loops and ending up with Jupyter notebooks in the cloud. For some of these steps, I'll be assuming you're using VS Code, but you should be fine if you're using a different IDE. The steps will pretty much be the same. You'll notice I'm only going over 5 different ways to run Python code, but in binary, that's 101. So, yeah, sorry. So let's get started with read-eval print loops and let's jump in. Okay, before getting into the Python terminal, I want to activate my virtual environment here. I'm in Windows, so it's going to be in scripts, the scripts folder. If you're in Mac or Linux, it's in bin. Okay, so we see that we're in a virtual environment now. To enter our Python interactive shell, Python terminal, or Python prompt, we need to enter the Python command. Now, this will show us what Python version we're running and some other information. On some systems that have Python 2 installed, this Python command will point to Python 2, so you'll need to enter Python 3 to get to Python version 3. Python 2 was deprecated in 2020, so hopefully eventually that will go away, so you'll just be able to directly go to Python 3 with the Python command. So, okay, so now we've gone from our system prompt to our Python interactive shell, which is shown by this set of 3 greater than signs, and we can start entering Python code. So the rep loop or REPL is really helpful for just quickly getting real-time feedback on your code, checking out if different packages you installed have actually installed correctly and are working. I use it, say, if I'm doing deep learning, PyTorch or TensorFlow, to see if they're actually connected to my GPU. And it's just good for really quickly checking and seeing how things are going. And if you have to SSH into work and you can't use an IDE and it's just you and your terminal, then this is how you're going to run Python code. So it's really useful to be able to run code this way. So the REPL loop is the Python interpreter reads your code, evaluates it, and then prints out the response. And then it loops back and does it again. There's not a whole lot of functionality here, but there's a little bit. So there's some basic syntax. It's sensitive to the syntax of the language. So if I want to do an if block, it will print out 3 dots to indent it for me. And then I have to enter twice to get out of that block because I might want to do an else or if else. And there's some useful features like, so let's do a quick import. Now let's just print out an integer between 1 and 10. So if you hit an underscore, it will actually print out the most recent object that was returned. Also, you can click up and down to go through your command history if you want to just get back to something you did, if say there was an error you want to fix. So that's pretty useful. So I don't want to go too in the weeds here, but this is just a really useful way to quickly run Python code. And again, if you're working remotely and you just have a terminal, this is how you're going to run code. So it's really useful, a really useful tool. More typically, you'll be at your system prompt running Python modules. So that's what we're going to get to next. But you need to get out of your Python terminal. And to do that, you just hit exit with parentheses. And next, we will go to running Python modules. So next up, we will look at how to run Python files from the command line. All right, let's go over how to run modules, Python files from the command line. So I'm in VS Code. So let's open a terminal. So I have it set up so that VS Code automatically activates the virtual environment from the directory I'm in. If you don't have it set up that way, you can run the commands to activate your virtual environment that we went over in the previous section on REPL. So the way to run a module from the command line is just Python and then the module name. So this is a really helpful module. It's called Math Ninja. It's got some great math functions, add, subtract. I have a feeling it's going to become really popular. So when we run this, nothing happens because we've just defined some functions. We're not actually doing anything. So let's actually print out some applications of these functions. And then rerun the code. We save the file. Okay, so now we see that it's added 1 and 2, taking the difference 2 and 1, we get 3 and 1. Great, it seems to work. But like I said, I have a feeling that Math Ninja is going to become a pretty popular module. And I'm going to want to distribute it to my friends, and they're going to want to import it and then use these functions. And what happens when you import this? So that's another way to use a module. So we want to get into the Python command line and import Math Ninja. What happens then? Okay, that's kind of weird. We still see those same results. And the reason we see that is because even when you import a module, it runs all the code in that module, even all your print statements. And that can be pretty annoying. You don't want a bunch of outputs printed in your module if this is code that you're going to distribute to your friends. So let's close out of this and think about what to do. Oops, let's exit out of this and think about what to do. So the nice thing is Python has a way to handle that, and it's with this name variable. So let's look at that. So whenever a Python module is run, it's assigned a name variable, and the value of that variable depends on how you've run that module. So if you've run it directly from the command line, the value of that variable name is called main. So, and then you can use that to alter the behavior of your function if you're working on it. So if I'm tooling around with a module and I'm doing little tests like this, and these are the ones I just want to run locally when I'm developing, I can embed them, those little tests, in this if name equals main clause, in this if name equals main block. And now if I have that, the people that import it won't see it, because when you import a module, the name is the value of the name variable is just the actual name of the file. So the name, the value of the name variable will actually be Math Ninja when you import it. And we can prove that. Let's run so that's why I added this print my name function. It prints the name of the module that's been assigned to it by Python. So this just prints the value of the name variable. So let's run that as well. So now let's run that module. So now we're getting the outputs of these two, because this is evaluated to true. So name is indeed main because we're running it from the command line. So we get these tests. We're testing out our functions. So add and subtract work well. And also print my name, which prints the name, the value of that variable name, and indeed is main as promised. But also, just as an additional test, let's import it, and just to show what the name variable evaluates to when you do an import. Okay, now that we've got print my name printing out within the main body of the module outside the scope of if name equals main, let's see what it prints out. So let's go into REPL and let's import Math Ninja. So you see now it's printing out Math Ninja, demonstrating that now the module, that the name variable's value is Math Ninja. And now we can use the different functions inside Math Ninja. Because we want people to use this module, we want to be able to distribute it to people. Now they'll be able to use it without it getting cluttered with all the testing and playing around that we want to do with our module. Now, of course, we'd want to get rid of that, but we did that just for purposes of this demonstration. So we looked at a couple of different ways to run modules from the command line. We looked at the Python command line and the system terminal, and Python treats those pretty differently based on how it assigns the values to this name variable. And you can take advantage of that with this you'll see this a lot with this if name equals main construct. And you can take advantage of that when you're developing your own Python modules and packages and sending things to people. So if you have this if name equals main, that's basically telling other people, like, I've been working on code and you don't have to worry about this. When you import it, you're not going to see any of this stuff executed. So next up, we're going to go on to running code cells using IPython in VS Code, and we'll do that next. All right, so next up, we are going to talk about running code cells in Visual Studio Code. This depends on IPython. I'm going to show you what you need to install and the settings you need to change in VS Code to get this running. So let's get started. All right, we are in Visual Studio Code, and I have my virtual environment activated. I've opened up a brand new Python file called Code Cell Playground or Code Cell Play. But before we can start working with this powerful new way to interactively run Python code, we need to do a couple of things. First, we're just going to install a new package called Jupyter. So we're just going to do pip. So install Jupyter. This will install all the things you need to run the rest of this stuff in this video. I already have it installed. I already have everything installed, but if you don't, it may take a little longer. For me, it just ran through saying you already have all this stuff installed. What are you doing? But for you, it probably will take a little bit longer. And then you need to go, there's some extensions you need to make sure you have set up in VS Code. So you can click this little icon, and there's Jupyter. You want to have the Jupyter extension. So you want to make sure you have that. So I already have the Jupyter extension installed and enabled. So you just want to make sure you find the Jupyter extension and install it. And then you'll be able to use all these sweet tools. So the best way to kind of explain code cells is to just show how they work. So a code cell is delimited in VS Code with the # followed by 2 percentage signs. And so now you see this, it says run cell, run below, or debug cell. So now we'll just do print world, and let's say create. Also, let's make a new dictionary, new data equals Let's make a new dictionary of silly values. And the nice thing is you can just run this code within this cell in an isolated way without having to run this entire module or without having to highlight it and then run it. So it just will run by itself. So what it will do is it will open up a panel on the right-hand side and run it using IPython. I'm not going to get into the weeds with what IPython is. It's just an alternate way of interactively running code. What I really like about code cells is it lets you really quickly iterate and build muscle memory with new concepts. So if I'm learning about a new concept, I will just quickly test it out and run it with different code cells. So there's really not much more to it, but I find it incredibly useful to just quickly iterate through code, and I can just keep editing and add new little bits and just add new code cells. And I don't have to keep, I don't have to make a new module. If I want to test out a new idea, I can just add a new code cell and just run that little code cell in isolation. And I just find it a really convenient little trick. So that's it for code cells. Okay, time to shift to running Jupyter notebooks locally. So Jupyter notebooks are really powerful. The reason I didn't spend too much time on code cells, even though I really like code cells, is because I think Jupyter notebooks are pretty much supplanting them. So let's go into more detail with Jupyter notebooks. So for people who attended my group session, this is going to be a little bit of repetition. So Jupyter stands for, it's a kind of concatenation of the program letters from the programming languages Julia, Python, and R. You can run code from all three languages in Jupyter if you set things up with the interpreters. I've also run JavaScript, and you can also, it also will recognize HTML. So Jupyter notebooks are a front-end, Jupyter provides a front-end web application that lets you create and share documents that are a mixture of text or markdown and code. It's a what you see is what you get, or WYSIWYG editor that lets you immediately see formatted text and executed code. You can launch it from your command line with the command either Jupyter Notebook or Jupyter Lab. I've already showed you how to install it, just it's pip install Jupyter. So Jupyter Notebook is the classic command. It's a little bit older and simplified. A lot of people like to start with that, but if you want a more modern, updated version of Jupyter, you want to use Jupyter Lab. So I use Jupyter Lab, but a lot of people prefer to start with Jupyter Notebook, and that's what I'm going to show today. Okay, so we're back in VS Code, and we're going to launch our Jupyter Notebook. So we've already installed Jupyter using pip install Jupyter. If you haven't done that, you can go ahead and do that. And to launch Jupyter Notebook, just enter the command at the command line interface, not from the Python terminal, Jupyter Notebook. And this isn't going to do anything in Jupyter in VS Code. What this will do is open up a tab in your browser. Okay, so once we launch Jupyter Notebook, we will end up on this dashboard page. This is basically the home screen for your Jupyter environment. Its main purpose is to display all the notebooks and files in the current directory from which you launched Jupyter Notebook. It has a few different features. It lets you, if you press this new drop down, it lets you launch a new Jupyter Notebook using Python 3. There's a few other options we're not going to focus on. You can upload a new file. You can also drop a file into the dashboard. If you click on a file, it will give you different options. You can open it, you can rename it, you can delete it. There's also a running tab. There's nothing in it right now, but if you have multiple files open and running, it will show you what they are. It will also let you stop them from running, that kind of thing. All right, let's launch a new Jupyter notebook. So we'll go to New, Python 3. So we've got a title here. Right now it's untitled. So let's create a new title. We'll just click on that title and we'll call it New Notebook, or let's call it First Notebook. Rename. And we've got a menu bar, which has a lot of options, and a toolbar with different icons we can click on. The file option has the option to create a new file, open a file. You can duplicate a file. So for instance, if someone sends you a Jupyter notebook, but you don't want to overwrite things in the original, you can duplicate it to create new changes. In View, I like to click Show Line Number so that in my code, if I have 50 lines and I get an error from the interpreter in line 25, I know exactly where to look. Under Help, you can get Show Keyboard Shortcuts if you want to look at all the keyboard shortcuts. I'll describe a couple of more helpful keyboard shortcuts as we go through here. And in the toolbar, one of the things we focus on was this drop down. It will tell you whether you are in a code or markdown cell, and also lets you switch between cells. And down here is where the brunt of the work is in the cells. So the cells default initially to being a code cell. We're going to start with doing some stuff in Markdown. So you can either use the drop down or use a keyboard shortcut. So the keyboard shortcut to switch from code to Markdown, or just switch to Markdown, is Escape M. And we'll write a little bit of Markdown. You can look up how to do Markdown online. It's pretty simple, but for instance, to do a header, you do £. And let's make a list. So you just use a dash. And then to run this cell and view it, you could just do Shift Enter, or you could click on this little play icon in the toolbar. But I'll just do Shift Enter. And then we could write some code in this code cell. You can also make equations in Markdown cells. So I'm going to switch this code cell back to Markdown, over to Markdown. So if you have an equation you need to render, like let's say you're going to implement some code write some code that implements an equation. Let's say dot x, which means a derivative, equals 1 over x. So this uses something called LaTeX, which is a really powerful equation rendering tool. Don't worry about the details if you don't know these details, but if you ever need really powerful equation rendering, you can do it using Markdown. Just put the equation between two $signs. You can also put images in there. So let's say you have the address, the URL of an image, or the local or a local path to an image. So I'm just going to look online here for a Python image real quick, and for the Python logo, and use that. So the way to render an image in Markdown. So look first, I often forget to switch from code to Markdown. So Escape M, switch to Markdown. So first an exclamation point and then brackets, we're to put the alternate text. So Python logo and then parentheses. The way I remember to do brackets then parentheses is I imagine I'm making a function where the argument is the address or path to the image. And that may look kind of big. If you want to do more fancy rendering of an image where you can control the size, you can use HTML. So here we are in a cell. Let's just do, we can do anything we want with code. So if you want to create a dictionary, the variable that's a dictionary. But let's say we were sitting here like, oh, wait, I want to put a markdown cell above this. You could do, there's a lot of keyboard shortcuts. You could do escape A. So some useful keyboard shortcuts. Place cell above. Escape B, place cell below. Escape M, make cell markdown, and escape Y, make cell code cell. You can also do up, down, move around cells. Oh, there's one other shortcut that I use. Use it. You want to be careful. Oops. It's escape D. So you have to D twice. Delete cell. So notice I just did the indent. So I did a tab on that. So that actually does kind of code formatting. So Markdown is pretty powerful. There's a whole lot about it. I'll put a link under the video with an introduction to Markdown to do more fancy Markdown. You can do a lot with it. Oh, one more thing I want to, so let's go back to our dashboard. So there's one thing I wanted to point out. So in our dashboard, so there's a bunch of files here and they all pretty much look the same, but notice the one that's running has a little green dot next to it. All right, so the canonical way to run Jupyter Notebooks is in your browser, but you can run them pretty much anywhere. You can run them in VS Code and in different cloud platforms. We're going to look at Kaggle next, but I just wanted to show you how to run them in VS Code. So we're back to VS Code. We've got our terminal with our virtual environment set up, and we're in the folder where we have our first notebook. So let's open that up. And we see, and remember that we already have installed Jupyter in this virtual environment, and we have installed the Jupyter extension in VS Code. So, and given that setup, it's rendering properly. The Markdown is rendering properly. The code is working. We see our equation, we see our image, and everything is looking reasonable. Things are a little bit different. There's a little play button next to each cell, which is actually pretty convenient. There's little buttons for running cells above and below the current cell. You can delete the cell. And there's stuff that's maybe less convenient. It doesn't have the same menu and toolbar that you have when you run it in the browser. There's a nice little icon that shows what virtual environment you're in currently. If that's not there and you start trying to run code, you'll probably get a little warning that you need to indicate the virtual environment, and you'll get a drop-down menu letting you pick which virtual environment to run. VS Code is pretty smart that way. So I just wanted to put this here to show you what it's like if you try to open a Jupyter Notebook from within VS Code. You can totally do it, and I sometimes work on Jupyter Notebooks from within VS Code, just if I want to do everything in VS Code. I prefer to typically do them in browsers just because that's what I'm used to, and I like having the menu and the toolbar and everything. But you can totally work this way, and some people prefer to just have everything in one place. So I wanted to cover that. But the next step is Kaggle, and if you're comfortable with things up to this point, Kaggle is going to be a piece of cake because Kaggle pretty much matches what you have locally in your browser. So let's get to that next. All right, finally, we're going to talk about how to run Jupyter Notebooks in the cloud. All the cloud providers, AWS, from Amazon, Google Colab, Microsoft Azure, and also Kaggle let you run Jupyter Notebooks online in the cloud. That's one of the reasons they're so popular. And as we'll see, one of the nice things about the cloud computing platforms like Google Colab and Kaggle, you don't have to spend a lot of time setting up a virtual environment. They have all the major packages in the Python data science ecosystem already pre-installed for you. So if you need to use NumPy, Matplotlib, TensorFlow, Pandas to do plotting and basic data analysis, you can just import them. You don't have to do any pip install or anything. You can just hit the ground running and start doing your analysis. And this includes Kaggle, which we're going to get to now. So here we are at the Kaggle homepage. I've already created an account. You can set up an account there using Google, and you can click on this create button on the left-hand side to create a new notebook. And so notice this looks a lot more like the regular Jupyter notebook that you start in your browser locally. So you've got a menu system and a toolbar. It pre-populates the first code cell just with some basic instructions. I'm just going to delete that and do some basic imports just to show you that without doing any installation myself, you can import NumPy as NumPy, import pandas, and just shift enter as usual, and it will do those imports. Depending on their servers, things can be a little bit slower when you're working in the cloud. That's why if you really need to work quickly, it can be better to work locally. The syntax for setting things up in Markdown is the same. I just used the same keyboard shortcut. So that's one of the reasons I like Kaggle compared to, say, Google Colab. The keyboard shortcuts are all pretty much the same. So notice when you first start a Kaggle notebook, it's defaults to being private. So if you want to share it, you can click share and then you can make it public. I'm not making this one public. You can click on the name of it and rename it. First time Kaggle, say. So we can make a list just like we did locally. So everything is the same. So it's really nice. But there's actually a little toolbar that's really helpful when you do a code cell, a markdown cell. So in some ways it's more helpful than the local Jupyter notebook. So if I want to do something in bold, list item 2, bold, so I can highlight that. So if you want to do something in bold, you put 2 asterisks around it. Item 3, italics. So that's going to be 1 asterisk. You don't have to remember that. And this is actually a really useful way to learn how to do Markdown, is to come to Kaggle and just use some of these items in the Markdown toolbar. So that's how you use a Kaggle notebook. It's just like doing it locally, and you can just hit the ground running because it has things installed already. And there's if you want to add a code cell, you can just click here. It will add a new code cell. If you want to add a new Markdown cell, it would automatically do that. You don't have to remember any of the shortcuts. So in some ways, it's easier than doing it with the installed local version. So that's how you get started with Kaggle. Happy coding. I hope this was a useful video. If you have any questions, please ask them in the comments, and good luck.